Okay, um, class, today we are going to be talking a little about time series section. The book that you are to read is Statistics for Business and Economics. Sorry, it's not showing at the moment because there's some system error, and the book is by Anderson and Jeffrey and Sweeney. So this is Statistics for Business and Economics, and this is the 13th edition. And the publisher is Engage. Now, what we are going to be studying today is the um, averages. The concept of average is very clear to you that you have some values, x, and then you just add them up and then you divide it by the number of observations that you have. So now, in this case, we have, okay, so this is just one section. There's another book by David Collier, and this book is Operations Management, and you can have any latest edition that is available to you. And this is one of the exhibits, 11 onwards, where you have different topics like forecasting, time series, seasonality, exponential smoothing, and moving average. So today we are going to be talking about moving average. We have weighted moving average, and then we have exponential smoothing. Now, exponential smoothing is basically just a rule of thumb to, taper down the values of the weights that are already assigned. So if you see that demand of a particular product, well, this could be any product at the moment, right? And this product has, let's suppose, 650 units in month first. And as you can see, now every month you have a steady amount of demand of that unit, and they are increasing initially, and then there's a decline, and then increasing, and then there's a decline. Now you need to understand the pattern by how much is the 3-month moving average, which is actually when you ignore the first 3 months. So if it was like 2-month moving average, you would just ignore the first 2 months. So the moving average concept is that you will just keep on relating previous, this is just an average that moves with the months. So you relate by the amount of months as gap that has been provided to you. So if the gap is like 4-month moving average, that would be just, you have 4 months, you just leave those and then you include the first average in the 5th one. So now since this was a 3rd month moving average, so you're going to just leaving the 3 initially, and then you just calculate the average in the 4th month. So what does this basically mean? It means that you have the averages that are moving along with the months, and you need to understand the trend. This is very important for trend analysis. What is the basic behavior? So in order to determine an accurate way, it is always better to have a seasonal analysis or trend analysis. So now with a moving average, it would mean that we are going to be having first 3 months, as blank, because you want to determine the average after the 3rd month, and then you're going to keep on moving by a 3-month gap in the next month. So that is why you move the gap onwards for each following month. So then that is why it's known as the 3-month moving average. So you have, in this case, 650, 700, and 810. These are the values of the values. These are just the units of the demanded product. And you divide it by the 3. This is, like I told you, so n is the number of values that you have. So in this case, it's just the month that we have. And you have 720, 730 for the next. As you can see, then the initial month will skip. And then the next 3 months will follow. So you have 700, 810, and 800. Just make sure there's not the current month which is included for the average, because a current month is beginning, whereas the previous months have ended. So you always have that thing which is ended. So you can always compare that instead of the beginning month, because the beginning, let's suppose I want to know about May. So 1st May, how would I know how am I performing in May, right? So you need to have a previous month. So you have 700, 810, 800 by 3. Then again for 700, you would have 810, excuse me, 800 plus 900 by 3. And now you would, since you just want for the 6 months, so you are going to slightly move to the 7th month, like the process of depreciation, where we have to spill over in, if you have half year convention, just recall that half year convention where you spill over the depreciation in the extra month just to have 1 year completed. Similarly, you need to know what is the performance in the 6 months. In this case, you just have 4, 5, and 6. So you have 800, 900, 700, and you divide by 3, so you have the value. So this is just the 3-month moving average. Now the other concept is 3-month weighted moving average. Now in this case, you already have the demand with you, and now I say that the weights are like 20%, 30%, and 50% for the 3 months. So for the first month that you are including would have 20%, and this would remain constant irrespective of the month demanded. The month in which the quantity is demanded. So we have, let's say, 650, 700, 800. In this case, 810. So we have 650 with 20%, 700 by 0.3, and 810 by 0.5. Then you don't divide it by anything because you already have this divided, okay? So this is 745. Next we have 700 by 20%, 810 by 30%, and 810 by 30%, and 800 by 50%. So now you have, in this case, is 783. Then again, just the same values, just multiplying it with the weights instead of dividing it by the number of months. This is going to be the weighted moving average because you assign weights to the quantity of the product that is demanded for each month, and these are irrespective of the number of the particular number of the month. So these are the weights that you assign for the first month as this, the second month that you're taking as 30%, and the fifth, this is 50% for the third month. So you have first month, second, third. So if you have 4 months, then you have 4 weights assigned, and so on. So this is very moving. Next, we have exponential smoothing as 10% alpha because we need to be, this is not the same as we say the confidence interval, but we have alpha over there as well. This is basically just to taper down the values. The rule of thumb to have the value reduced or having the impact of reducing the weights. So you have the weights as not just 10%. So in this case, it's going to be 0.1, and then it's 10, and then it's 90% for the first value. Because in this case, now the demanded. So now you have the weights in the weighted moving average. But when it comes to exponential smoothing, so it's like an exponentially reducing the value to some extent, reducing the impact of the weight. So in this case, you just want to basically understand whether reducing the weight would have any impact on the deviations that we're going to be calculating further. So now we have the demand in this case, and this is for this next month. Now do remember that since we don't have any exponential smoothing here, so we have to take this demand because this exponential for the first month will only happen at the end of that first month and the beginning of the second month when this month's values enter into second month. So for the first month, we don't from 0 to 30th, I suppose, of April, we won't have any values. So the next month, we will be knowing what is the value of the first month's demand, or is it getting affected, or does it have any impact on the next month's demand. So we have, in this case, 10% of 650 plus 90% of 650 as 650. But in the next case, as you can see for the third month, then we have now this value, okay, so this is just going to be the previous value plus this weighted demand. Okay, so this is exponentially smoothed out demand. So we have 0.9 of 650, slightly reduced the value, so 0.9 of 650 and the 0.1 of 700. So initially, if you see the first value that was 650, we took both as 10, and both the values were the same here as 10% and 90%. But for the next, the third month, we take this as 10%, and the next would be the smoothed out value 90%. Okay, so this is just going to be reducing the 700 demand impact, as you can see. So now then we have in the fourth month, as you can see, this is again 810 into 10% plus again 655 into 90%. To 670.9. Now you can just see that it has been tapered down, it has simmered down, it has boiled down to this value, it has reduced in fact. So you can't from 810. So we need to basically taper down these values to not overestimate, and we want to be accurate but in a conservative way. So just the way we do that in accounting, we have to be conservative and prudent in our reporting. Then similarly, just 900, so just multiply the 10% with 800, the previous value by the 10% if it is alpha as 0.1. So this is 10%, and then you have again this value, 670.5 90%. So more than this, the end result will be slightly more than this but less than this. And then you have 900 into 0.1 plus 90% of 683. Okay, it's just basically reducing that from being reported as it is in the next month, because the logic is that in the next month this demand would not be exactly the same. So although these the product that you have made would be demanded, but the demand would be slightly impacted by the next month's say this the product that you made in the first month has to be somewhat might not be able to fully sell in the first month. So even if you demand these values would slightly be increased, might show some increase in the second month, and the impact of the second month would also impact that number of unit, the or the quantity demanded, basically the number of units that you demand per person. So then you have this value as 705. So this is less than 900, and because all the parts for the previous months are not completely sold, so this is also getting impacted by lost in first out method. So it has the impact of this notion in this to consider selling out the previous month's products first. So the demand would be actually impacted by the previous month's products relative to the current month's products. Then you have, now it has to again spill over to the other month because we also have to take into account this month. So 700 into 0.1 and 6, so this is 0.9 to 705.2, and you have 704.7. So now we'll see actually what is the deviation. Deviation is basically just the differences between all these averages that you have and the smooth out value. This is 800 minus 720, 900 minus 770, and you can just have any differences. So this, as you can see, this values for mean absolute deviation, and you don't have to necessarily do the exercise, just look at the examples, and you have to, this is just going to be a big help to you for the main book, which is Business and Statistics by Sweeney. And if you look at this example, we have demand 8, 9, and 700. So this is the last 3 months prior to finishing over, or prior to touchdown, I would say. This is 8, 9, and this mean absolute deviation would be 3-month moving average for the last 3 months. And this is because it has the impact of all previous months included in that. So the difference is between 720, 770, and 837 in this case. And then you just have this as absolute value, because any negatives would be erased in this process, and you have, for this particular process, you have the absolute deviation as a positive number. And then you just add them up, like 80, 130 plus 137 is 247 by 3. So you just get the sum of absolute and then mean absolute deviation, so you can just say it's not as short. Then what we usually call it as mean absolute deviation. Then again, we have the same demand, the quantity demand here, as you can see, it's 800, 900, 700. But we have the moving average. Now, instead of subtracting this, we are going to be subtracting these values. So we have 745, 783, and 8. So now, again, these values, right? So we're not going to be doing this at the moment because it doesn't have any demanded quantity. But we have these values, 745, 783 is corresponding ones, and you just subtract any negatives or convert into positives. You know, erasing the negative portion or deleting that, canceling it out basically. So you divided that by 3 and you get 1 degree. So you can see that by weighted moving average is lower than the mean absolute deviation for the simple moving average. So that means that this is a much better method because we have mean absolute deviation lower than the um, uh, previous by the method calculated by this moving average method. Simple moving average is all. It's also known as simple moving average. Then we have the third part, which is just having these exponential smoothing values, which were 683, 705, sorry, 670, 683, and 705, leaving out this last one, 670, 683, and 705. So as you can see, 670, 683, 705, you have these values, and you just reduce the negatives if there are any, and then you divide by 3. So this is the, I guess, still higher, but lower than the, or this is the highest, okay, so this is 117, this has the most deviation. And because obviously you are trying to uh, uh, gauge to a different altogether, method. It's not assigning any weights, it's just reducing it exponentially and uh, by, this alpha. Basically, the concept of alpha is that you have to taper down the weights. So when you reduce the weights, it's just going to increase the deviation. So assigning weights and more or less not too much of a difference in each value of quantity demanded, so that won't have much of an impact overall. Or overall value won't be impacted that much, so the mean difference as reported would not be too exorbitant, I would say, so it's not going to be too pronounced. So in this case, we have this as the lowest, and this is the best method to evaluate. As they can, they're saying in here that it's 3-month weighted when we have the lowest map, and the best forecast method among the three because of the. So if someone asks you what is the best forecast method, that's how you determine it by mean absolute deviations. So the control limit is basically when you have the incremental values increase with the difference of or difference could be of a plus or minus going from one negative side to the positive side of the graph, and you're just actually drawing it in the graph. So you have this exhibit 11.11, and but even if you know that the mean absolute deviations in terms of numbers, so it's just if you have 4 deviations, that means that there is actually not the it is not the same as 108. It means that the total, if you have the difference from the main value, which is reported as these are the control limits basically for a range of max, that how many differences can arise between the various values of max. So these could be as -1, 2, or 3. The various methods are employed to calculate it. So accuracy, if it's 57%, if just with a control limit of 1. So you can also find out the concept of control limit on the book, but somehow it's missing error. So as you can see, this is operations management book with so you can just read it up here more. It's just about the concept of maximum or minimum values that have after trend has been analyzed. So it's control limit rather than to have the main value of this whole value. You're just considering this value rather than the limit that you want to assign to a particular uh, you know graph that you see that you can have as plotted or the trend. So with these numbers, they just tell you that as the number of mean absolute deviations are having this flexibility to have the control limit increased, so the accuracy would be more, because it's just similar to saying that if I have alpha of 10%, then I would be confident 90%. Okay, but if I reduce alpha, so my confidence level would be up, right? Similarly, I have that notion is a bit tricky to understand, that in this case, you are just giving them more of a leverage to assign error to a particular value. So you're allowing the calculations to have this flexibility to deviate from the mean value by 4 points per value. So this could have the, if you allow this in your system, then you can have 99% accuracy. But if you don't allow the value to be flexible enough to deviate more than just 1 point, so the accuracy in this case would be less, or the system would report as less accurate, because you have not given margin to the system to allow for that error. So it is going to report that as inaccurate. Anything that goes beyond 1 will be inaccurate, so the accuracy level would be reported as low in this case. But for alpha, where we have, if we are too confident, like 99%, and if our, then there's going to be a very short margin of error, right? So if I say that I'm confident 99%, so my alpha is 0.01, and then if I have too much of a confidence, then I can't report error in this case. Similarly, for absolute deviations like standard deviation, you have, so if you keep lowering the values of deviations, you are going to be upping your confidence level. So you can't report error basically. So your upper error limit, this is just a notion, it's also used in accounting, but it's known as upper error limit. And upper error limit, you are reducing that. So with upper limit reduced, the error reporting would increase. So the accuracy would be reported as less. It's not that it's not accurate, but if you just keep on increasing the margin, it's going to give you more accuracy, because then the system would allow anything more than 1 to be inaccurate as not error. Okay, it's not going to be an error in that case. So you just look at this, we have already done the regression part. So today's concepts are related with control limits for range of mass. Then we have the absolute deviation per average or for smoothing, and then these are uh, the values that you have to plot, and you have to observe the trends in this case. And there are 2 books that I've already told you. One is by Sweeney, and this is the business statistics book, and the chapter that you're going to be studying is chapter 17, okay? I'm unable to open it even though I have this with me, but somehow there's an error generated. I'll try to open the book, but so it does not. So I don't know, I'm unable to open this. Let me just convert this to PDF. Okay. So now we have this chapter 17. So I don't know why it's not opening at the moment. It's just tiny. Okay, so now in this book, as just look at this. Let's increase the percentage. See, you have to do section 17.1 in this time series horizontal patterns. It's just the graphs we've done. Graphs enough already, just seasonal patterns. But moving average, this is the concept of in exponential smoothing that we did, section 17.3. You'll read that. And I would like you to at least look at 17.5 as well. So 17.1, 17.3, and 17.5. Okay? And the book is just the details of the book. Statistics for Business and Economics. and Bison Gage. And the authors are this David Anderson, Dennis Sweeney, Thomas A. Williams. This is the third edition. Okay, guys. So see you next time. Thank you very much.